Welcome to Project ReCollect, an interactive VR experience where participants traverse a landfill environment that has fallen victim to the toxic effects of e-waste. With all the electronics we have in our daily lives, they have to go somewhere when we're done with them. But the problem is there are too many electronics that aren't properly brought back into circulation and end up turning into e-waste, leading to larger carbon footprints that affect climate change. From our research, we found that although electronics have valuable materials, these are lost due to improper disposal. We also found that energy expended in manufacturing new electronics, including those that cause people to abandon the ones they own, have large negative effects on the environment. This led to the goal of the project, to enable participants to shift perspective on the values of their electronics and the decisions they can make regarding their acquisition and disposal that can lead to reducing negative impacts on climate change. By interacting with different types of electronics and having participants' actions affect the environment, the desired user experience is intended to be engaging, yet approachable to allow participants to feel comfortable, in control, and curious about their objective to enable reflection. To do this, we utilize VR's affordances for immersion and active participation that enables participants to be invested in an experience and better remember key moments that were tied to their virtual actions, allowing for a stronger reflection post-experience. The media interaction framework acted as our foundation for VR immersion. Sensory immersion is used to increase sense of presence and reduce external distractions. Visuals that make up the environment create a sense of atmosphere when coupled with ambient sounds and allow participants agency to move in different directions. Sound is also used to provide immediate feedback for interactions to align with participants' expectations of how objects react to their actions. Challenge-based immersion is used to provide the participant motivation through the form of an objective and setbacks. Imaginative immersion is introduced by allowing the participant to use the narrative we present as a foundation for their subjective experience. The narrative is set in the near future where our team acts as a group of researchers revisiting an old research site in a landfill area that became too dangerous due to toxicity levels. Although research utilities are stationed there, the site has not been active for a while. Luckily, the site can now be revisited using a robot built for toxic conditions that is stationed on-site and controlled remotely. Participants act as a volunteer to operate the robot and are given a mission: to identify and mine electronic devices to reduce toxicity and collect materials for our research. For our physical setup, participants walk into a tent that acts as a remote research station and are greeted by our team dressed as researchers. Monitors are set up on the table to the left for our team. An adjacent table showcases a selection of electronic parts and commonly found older devices. This is to let participants see examples of familiar devices that can still be recycled. The organization of the tables and seating area is intended to allow for some privacy. We also present images of what the research site used to look like and what it has become, along with a poster of our research group logo that is also seen in the virtual environment. Before starting the experience, participants are instructed on how to control the robot and tool that they use to collect materials. When the experience begins, participants start with a robotic activation sound to support imaginative immersion, and are immediately presented with a large machine known as the tool vendor and a mining tool used to collect materials from mineable devices. As participants become familiar with the environment, they encounter toxic particles that stop them from moving forward, indicating that the area ahead is too toxic. They find devices that are identified through a UI for the robot, indicating recyclability and toxicity. In our research, we found some new devices have more toxic and less recyclable components than older devices, making improper disposal in landfills even worse. We design a pattern where newer devices, represented by smartphones, are more toxic. Once a toxic device in an area is mined, the toxic particles ahead dissipate, allowing the participant to progress. The toxicity of newer devices break the mining tool when devices are mined, and participants must go back to the tool vendor. They must decide either to reuse their tool by repairing it or replace it with a new tool. Selecting repair outputs a fixed tool with a blue mist. Selecting new outputs black smoke with shards, with a new tool to express the manufacturing cost on the environment. This is further emphasized by increased density and color of global fog as a result of the pollutants in the manufacturing process reacting with the toxicity left in the environment. They can continue exploring, but each time the tool breaks, although not often, requires them to return to the tool vendor. Another aspect of going back to the tool vendor is that when they return to where they last progressed, they will find that a new path was revealed when they mined a toxic device, acting as a reward. Eventually, they reach the end deposit area. The logo and research artifacts are used to differentiate this area and indicate that there used to be more utilities. The only operational one is the deposit pipe. It leverages visual and interaction cues participants are familiar with from their experience with the tool vendor. Participants are given control to complete the mission by pressing the blue button. They are told beforehand that the robot is programmed to go offline as soon as the mission is complete, and this is symbolized by a fade to black. After the virtual experience, we ask participants questions about how they treat their personal electronics, along with their thoughts on the actions and decisions they made in our experience. This is intended to allow for reflection and emphasize our message. We began with the first prototype, where we tested the SteamVR interaction framework. We followed with testing the linear path and noticed an opportunity to modify the focal points of the level to help communicate the idea that the decisions that the player makes has a direct negative or positive impact on the environment. During our design discussions and user test, we noticed a couple of problems with our linear design concept. Firstly, to address the issues with players not noticing the focal points, we wanted to make sure that the player can explore key points of the level multiple times to see the different toxic states of the level. This would help the feeling of discovery and assist in exploration. Secondly, due to the time constraints that we had for development and the assets to be found, we wanted to pivot to a circular level design, which we believe would be best suited for this kind of design. The tool vendor's appearance took various forms. We designed the procedure of interactions to be easy to recall and walk through. However, during our design discussions and user testing, we noticed there may be issues in the hierarchy of the vendor components that hinders the attention to both the instruction screen and tool compartment. We then tested different configuration of screen, buttons, and tool compartment. We hope that through this experience, participants are able to walk away more informed on the value of electronics and the impact of their decisions in regards to the disposal and acquisition of electronics to potentially shift perspective.